Okay guys, we're back on the Olds heads. Now, took a bunch of work. I actually had to go out and buy some hardware and stuff to bolt those plates to my bore adapter, and then wasted a month's salary just getting some duct tape. It's insane how expensive things are right now. You guys need to fix that for me. I'm very busy in the garage. I can't help you. But we have some non-leaking flows. And before we look at the numbers, somebody's going to say, "Oh, Charlie, you ruined those." And I'm going to prove that I didn't ruin them. And I'm going to show you why. First things first. If you take a look at that splatter of Dykem, notice how much wider it is than our first one. Notice that it is a little bit on the other side of the guide. It is in the same direction as the last splatter. You can see one splatter over the other one. It's a little bit narrow, probably because I sprayed a touch less. But it's much wider down here, right? And when you see the bore, you'll know where the rest of that went. Okay, the bore is a total win. Look at how wide that is all the way around. That is a complete win. Way different than what we had to begin with. I think we have a win on the valve itself. And it looks pretty good down its throat. Now, I think our next phase on this intake port, I'm not sure what I want to do. In reality, when we take a look at the air speeds on the roof needs to be filled. We may try that. You can give me your input on the comments, guys. Okay, last time we had some right on the short side radius. I really don't see anything on the short side radius, but it sure looks a lot better down the bowl. The short side radius did get a touch of work to even the speeds out. We'll see how I did on that. Okay guys, this was the last time I did it. I know I still had leakage, and I explained it in the video. Problem with leakage is you don't know how it's going to affect your curve, right? Well, this has got zero leakage. This is good now. I had to make up gaskets and stuff. Yeah, we're all minuses compared to that. But in reality, it's better, and I'm going to show you why. You know what's really interesting is take a look at our swirl, right? That's what our swirl was. That's what our swirl is. It's minus everywhere. We got a reversal at the very bottom, then 0, then low, 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 and then it goes backwards. I need to think about that. In any case, I'm not thrilled with our swirl curve. Now let's take a look at our push rod pinch speeds versus now. On top it went down a touch, in the middle it went up quite a bit, and on the bottom it went down a little bit. Which means this absolute center of that push rod pinch is more active. Which is why we don't have any blue on the short side. Over here we had more air following that short side up. Remember, that short side is really steep. Okay? Now, let's take a look at our roof numbers. 151, 135. That's low, right? Guess what? I improved the short side, and look what happened. The roof died. Okay? Really slow. They are nice and even, but they're really slow. Now take a look at our short side. 280, 355, 309. Plus, plus, plus. Short side working way better. And you have to remember, it's a super curved type port. So everything wants to go along the floor and out. The roof doesn't need to be nearly as big as it is. I'm willing to bet I can shrink that roof considerably and still get almost the identical flows. Now, that may not be what the owner wants, but it'll be interesting to test. It's you know it's bad when you can use a 1/2-inch flow ball. 1/2-inch flow ball right in the roof of the port. You would think that would make a huge disruption and completely change the airflow and reduce your CFM. What happens if you put a 1/2-inch flow ball in there and it doesn't do anything to the flow? That area of the port is not restricted. In fact, there's hardly any air going through that. You're better off filling it. I'll show you how that lays in the port. Okay, that's about what it looks like. Doesn't change the CFM at all. And you take it and you put it on the other side, and it changed it by like 1 CFM. So what does that tell you? Okay, this whole area here is too big already. So I may do that first. Let's take a look at our exhaust flows. Okay, the exhaust port is the same as you saw it last time. I haven't changed anything on it. It still has a rough texture on it. I could polish it up and probably get a few more CFM out of it. But I did improve the shape on it. And you can see when the lifts start coming up, it definitely improves. Let's take a look. Okay, guys. This is what we had, but we had leakage. Don't forget we had leakage. I should have documented how much leakage I had, but I didn't. That was a mistake. Okay. What happens when you make a mistake, guys? Cry and move on, right? Okay, so we're done crying. This is what we got now. All minuses versus this, which doesn't surprise me, even though this port is working better. I'll prove it to you. Okay? We do have a little bit of noise in this area. That's going to knock our efficiency down a touch, no doubt. The rest of it works quite well. I mean, at a street lift, right, 600 for a big engine, 260, not bad. Put on pipe on it, 277. Now, over here it was almost 300, but how much of that is leakage? Don't know. All right, take a quick look at our what our speeds were and what our speeds are, right? Minus, plus, minus, minus, plus, 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 minus, plus. We got more pluses than we have minuses. And let's see, are we more even across? Look at how crooked that roof is right there. We got 300 on one side, 162 on the other. 283, 193. It's still crooked, but it's better than it was. It wants to come out on the center of the cylinder side. Look how high that corner is. And we got more in this corner than we had, by a lot. That was only 160. Look how much that came up, 205. Okay, in any case, I'm pretty sure that port is working better, except for that little min-range spot. There is something I'm thinking about doing to take a look at that. Stan Weiss sent me some Olds flows when I first put these videos out. Unfortunately, they're on the phone that I'm recording you right now, so I can't. I'll have to write them down and show you guys if I can remember to do it. Okay, this is why the short side works so much better than it did. Now remember, this originally had a fully radiused valve seat, which is going to be more efficient, but I couldn't even hold the valve closed to start the test. Well, the short side got a little bit of a reshape, but I couldn't do much because even though this is a custom casting, it was so thin I could see through it in spots. you could read a newspaper through it. It was so thin. So you really got to be careful where you take any metal off of it at this point. So I was only able to touch that short side a bit. You can see we got some body filler on that side. I did have to change that a touch. Okay, I do think it's interesting. I mean, look at the angle of our liquid flow, and yet it says it has very low swirl. I'm not 100% sure what's going on with that. I mean, the bowl itself looks pretty good at this point, but it's just too big, I think, for what we're doing, for how shrouded it is. I think we could shrink that up quite a bit. As far as my vein in the roof, I think it's pretty close. I could probably move that over a touch. What do you think about that, guys? You give me a little input. Remember, I'm not an Olds guy. I don't even know. I think I did one Oldsmobile. No, I did one. I think I did 2 sets of Olds heads years and years ago, and those were completely different. Right? One was an Olds 350, and the other one was an Olds 400. That was an interesting one. All right, so if you guys know some Olds secrets, fill me in. I could use a little help on this. All right, guys. What is it, Thursday? You know how I am on Thursdays. I'm cooked. They beat me like a red-headed stepchild all week. Oh, so nice to be needed. I'm sure you guys understand. Well, thanks for hanging out. Have a good night.